here's our video on rational numbers, part 1. So, in 7th grade we went over rational numbers. Let's review it here. So, here's a chart, and we have the real numbers, and they're usually written like that, with 2 lines like that. And those are every number that you've been learning since kindergarten. Those are all the numbers. Those are the real numbers. So we have our rational numbers over here, and it's usually we use a Q to denote rational numbers. And then, of course, there's irrational numbers we'll go over. Then there's, of course, the integers, which some use a Z for Zahlen. It's a German word for integers. We have the non-integers, which are fractions and decimals. We have our whole numbers. We have our negative numbers. We also have 0, because 0 is not a whole number. Or, I mean, 0 is not a natural number. It's a whole number. But some people put 0 by itself. And, of course, 0 is not negative. So we have our list here of our numbers. So rational numbers, they can be written in this form. Written in the form A over B. So A is a number and B is a number. Sometimes they write it like this, P over Q. So you can see them in both ways. The only thing about B is it can't be 0. It could be any number, it just cannot be 0. If you see a 0, if you see 5 over 0, that's undefined. Any number that's on top and 0 on the bottom is undefined. So remember, you can have 0 on top, you can have that, that's a rational number. But this is not a rational number. It's not irrational either, it's just undefined. So B has to be a non-zero integer. So again, you'll see it in this form, A over B, or you'll see it as P over Q. So that's the fraction. So rational numbers, they do 2 things. They either repeat with a pattern, it has to have a pattern, or terminate, stop, right? Terminate means stop. So let's look at a few here. Let's look at this one. This is 5/8. It's a fraction. If we can make it a decimal, and that decimal either terminates or repeats with a pattern, it's rational. So, what do? Well, we can test it out, put the 5 in the box, right? And 8 goes into 50. How many times? 6 times. Bring down the 2, and 8 goes into 20. Bring that line over like that. 2 times, and then we're left with 40, and there's our answer. It stops, 0.625. So we know that 5/8, 5 over 8, becomes 0.625, and it's a rational number. And 0.625, we know it's rational also because we can also put it over as a fraction. And that's an equivalent fraction. They're equivalent. Now, rational number could be negative. See if you can do this one. What is the decimal on this? So pause the tape and see if you can give me the decimal. Okay, so again, let's bring this over a little more. And keep in mind, we have a negative here. This is negative 3/12. So it doesn't matter where the negative is, by the way. You can even write it like that, negative 3/12. It's a negative number. So keep that in mind with our answer. So the 3 goes in the box. The top number always goes in the box. Put a dot, 0, extend. 12 goes into, 12 goes into 30 twice. So we have 24. Bring down the 6, and 12 goes into 60 5 times. So it's not 0.25. It's what? Bring that up. It's negative 0.25. And negative 0.25 is a rational number. So those are rational numbers. It terminates. In other words, there's no other numbers. Once you get 0, it terminates. So it terminates. That's what terminate means. So repeating decimals is the next type. The repeating decimals have to have a pattern. So if I did 0.521, 521, 521, well, we know this repeats. So what we would do is put a line over it. 0.521. That's a repeating decimal. Again, it has to have a pattern. The pattern is 521, 521, 521. Okay, let's look at these. Here we have a pattern, 0.22222222. The pattern is 2s. So it's actually 0.2 with a line on top. Let's look at this one. 0.34567, 34567, 34567. So it's repeating. So what you would do is put a line on top of it. It's a repeating decimal with a pattern. Now if it doesn't have a pattern and it keeps going, we don't call it a repeating decimal. We just say it's irrational. And we'll talk about that in a minute. So tell me what type of decimal this is. Is this a rational number? Try that by yourself. Okay, you put the 1 in the box, and 3 goes into 10. And as you can see, it's just going to keep repeating. So this is a repeating decimal. It has a pattern, 0.3333 forever. So you would write it as 0.3 with a line on top. That's a rational number. So another way we can sum this up, rational numbers can be made into a fraction and turned into a decimal as long as what? As long as what? For it to be rational, it has to either end, and what is another name for end? It has to terminate, or has to repeat with what? With a pattern. If it doesn't terminate, or it doesn't repeat with a pattern, it is not rational. And by the way, when we take a rational number, like 3/5, and we get the decimal, we say we're doing the decimal expansion. The decimal expansion. I'll write that up. Decimal expansion. And it just means we're taking the fraction and we're making a decimal. So if you see that on a test, make the decimal expansion, you're just taking the fraction and making it a decimal. Try this one. So here we have a decimal expansion. Try that. By the way, you should be familiar with this fraction. Okay, so if you're familiar with this number, you know that we use this number mostly in lower grades to denote pi. Pi is a famous irrational number, and we just say 3.14. However, we just use 22 over 7 to estimate pi. 22 over 7 is actually a rational number. It's not pi, it's just close to it. So it's actually a rational number. So what we do is we put the 22 in the box, and this will go on for a while, so we know that 7 goes into 22, you have a 21, right? And what you'll end up getting here, it'll just keep going, but eventually it will terminate. Okay, actually, if we even went to one more number, if we went to the 7, then it's going to repeat. So 22 over 7 is a rational number. In the decimal expansion, this is what you get. Now, you remember when you do this, let me just erase that. $3.142857. You have to put a line on it. If you don't put the line on it, then we're saying it's not a rational number. You do not want to see it with this. And we'll talk about that in a minute. That's called an ellipsis. And that's just saying that the number, there is some kind of number that follows this, and it goes on to infinity. We'll talk about that in a minute. Okay, let's look at one here. What if you saw a number like this? 1, 2, 3, 4, 3, 2, 2, 2. Bring that over. Is this a rational number? Well, yes, it's a rational number. You can make it a fraction. Remember, there's no decimal here. Put that all and just count. 10th, 100,000, 10,000, 100,000, million, 10 million, 100 million. That's the fraction. There are two integers. It's over the form a over b. B is not 0, so it is a rational number. Now, if they're not rational, they're irrational. And here's some of the famous ones. We know pi, 3.14, and it goes on forever. We have phi, or phi. Some people say phi in England, or we say phi in America. Okay, and that's 1.618 dot dot dot. Remember, there's the ellipsis. It goes on forever. That's why it's irrational. Phi is also called the golden ratio, which we'll talk about. One we'll talk about, square root of 2. That's a famous one, which we'll talk about. Now see if you, what is this number? Do you think this number is irrational or rational? You can tell right away it has the ellipsis. So if it has the ellipsis, this is irrational. We don't know what the next number is. We're saying there is a number next to it. You saw this with a line on top, then it's rational, because then you're saying the 1 repeats. But if you see the ellipsis, it's not rational. Remember that. So what about this one? Is this rational? Well, it seems like it has some kind of pattern here, does it? 0.12, 122, 12222, and so forth. This is actually irrational because it's not repeating. Remember, rational numbers need to repeat. The pattern needs to repeat. If it was 0.12, 12, 12, 12, 12 with a line, then it's rational. But here, even though it looks like there's some kind of pattern in your mind, because you're assuming the next number will be 1 and then 5 2s, it's still not repeating back. So that's why it's irrational. This is an irrational number. Okay. Oh, and I forgot about the E. Let's get a better marker. There's that, better marker. This is Euler's number. He's a famous mathematician. That's how you write it. But you pronounce it Euler. And it, it goes on forever. It's irrational. 2.178. Just remember it as 2.178. There's the ellipsis, so we know it's irrational. So again, it's Euler. Actually, it's an E. Euler. Not an R. Euler. Okay.